Hi, I welcome you all to this course on refrigeration and air conditioning. Today I'm going to discuss the basics of refrigeration, and then we'll see the applications of refrigeration and air conditioning in day-to-day life. So let us begin today's session with uh, the basics of with the uh, discussion on this refrigeration course in SPPU Pune University. So this refrigeration course for TE Mechanical Engineering is of total 100 marks, out of which 70 marks are assigned for in-sem examination, and there will be a 30 marks in-sem examination. The teaching scheme is like that: 3 hours per week lecture and one practical of 2 hours per week per batch. So prerequisite for this refrigeration and air conditioning course is that uh, you must know the basic of thermodynamics, which include various laws of thermodynamic, ideal gas processes, thermodynamic cycles, properties of pure substance, and basic of psychrometry. Also, you must know the fluid dynamics and heat transfer, and particularly the governing equation for heat transfer and heat exchangers. The course objectives of this course are learning the fundamental principles and different methods of refrigeration and air conditioning, to study various refrigeration cycles and evaluate performance using either Moyle charts or refrigerant property tables. Next is comparative study of different refrigerants with respect to the properties, applications, and environmental issues. Next is to understand the basic of air conditioning processes on psychrometry charts, calculate cooling load for its applications in comfort and industrial air conditioning. And lastly, the study of various equipment operating cycle of their operating principles, operating and safety controls employed in RAC. So the course outcome: at the end of this course, the students should be able to illustrate the fundamental principles and applications of RAC. Then they obtain the cooling capacity and coefficient of performance by conducting a test on VCR systems. They are able to present the properties, application, and environmental issues of different refrigerants. Students will able to calculate cooling load for designing the air conditioning system for various applications, and they'll able to operate and analyze the refrigeration and air conditioning system. So first unit of this refrigeration and air conditioning course is on application of refrigeration and air conditioning, and then the refrigerants. So today in this lecture, I am going to discuss the application and applications of refrigeration and air conditioning only. So different types of applications that we are dealing in day-to-day life are in domestic refrigerator, in domestic air conditioners, automotive air conditioners, evaporative coolers, water coolers, and when it comes to commercial refrigeration, we can directly or indirectly use for dairy, and then cold storages, ice plant, and in commercial air conditionings, as you can see in multiplex and hospitals air conditioning, we can use the refrigeration. So let us begin with uh, the basics of the refrigeration, its definition, and the principle of refrigeration. So, as per the American Society of Heating, Air Conditioning, and Refrigeration Engineers, that is ASHRAE, refrigeration is defined as the science of providing and maintaining the temperature below the immediate surrounding temperature, right? And of course, for this you need to remove heat from the medium so that the temperature of the object or the medium that you are going to refrigerate is always below than the surrounding temperature, right? So in short, you can say that refrigeration is the process of removing heat from the substance or the medium in order to keep that substance below the atmosphere, or below the immediate surrounding temperature, right? So for this heat removing in below the atmospheric temperature, for so refrigeration needs to give some work input. So as per the Clause's statement of second law of thermodynamics, so refrigeration works on the second law of thermodynamics, particularly the Clause's statement. And what the Clause's says is that whenever you have to remove heat from the object, that is a cold body in this case, and you need to give some work input, and then with the help of this refrigeration system, the heat from this cold body is removed, and that heat is rejected to hot body. Clear? So this is a second law of thermodynamic, and refrigeration works on this principle of refrigeration. Then unit of refrigeration is TR, that is a tons of refrigeration, and the capacity is expressed in TR, and one TR is defined as the amount and or the quantity of heat to be removed in order to and from 1 ton of ice at 0 degrees Celsius in 24 hours from liquid water at 0 degrees Celsius, right? So 1 ton ice production which is at 0 degrees Celsius in 24 hours from water which is at 0 degrees Celsius. So from an at 0 degrees Celsius you have to remove heat. How much heat you have to remove? That is 1 TR. So 1 TR is given as 12,600 kilojoule per hour, or 210 kilojoule per minute, or in kilowatt it is 3.5 kilowatt. So 1 TR is 3.5 kilowatt. Remember this number. Next, there are different types of refrigeration systems which is used in the industry. One is ice refrigeration, then evaporative refrigeration, refrigeration by expansion of air, refrigeration by throttling of the gas, refrigeration by vapor compression refrigeration cycle, by vapor absorption refrigeration cycle, steam jet refrigeration, refrigeration by using liquid gases, and dry ice refrigeration. So nine refrigeration systems are enlisted, but in this course of refrigeration and air conditioning we'll discuss mostly about fifth type, that is the vapor compression refrigeration, which accounts for more than 90% of the application in domestic as well as industrial applications today. So our focus in this course is mainly on vapor compression refrigeration cycle. Then we'll briefly discuss about vapor absorption system also, but rest of the systems are not will discuss in much depth in this course of refrigeration and air conditioning. So our focus will be on vapor compression refrigeration and vapor absorption system only. So let us begin with the discussion on vapor compression refrigeration system only. So this vapor compression refrigeration cycle is of it comprises of four components, that is the evaporator, compressor, uh, then condenser and expansion valve, as you can see here. Clear? So these four component, and this cycle is divided into two sections. One is the low pressure side and one is high pressure side. And of course low pressure side includes the expansion, then evaporator and suction of the compressor. Then after compression and condenser, these two components are at high pressure, right? So this is basically the heat. If you remember the previous slide on the uh, second law of thermodynamics, so object here is the object that whose heat you are going to remove, and that heat is removed as shown here at Q0, and that heat rejected to high temperature reservoir, that is surrounding in this case, uh, from the condenser. So heat is removed from the medium or the object at the operator, and it is rejected to the surrounding or the high temperature source, so reservoir from the condenser. Clear? But for this you need to give some work input which is generated by W in the form of electricity to the compressor. So this is the basic working principle of the vapor compression refrigeration cycle. And expansion device is doing the job is it actually um, works as is a pressure reducing device, and as you can see that after the expansion wall, the pressure high pressure is reduces to low pressure. So this expansion works as a pressure reducing uh, device. Next is coefficient of performance. The coefficient of performance, in order to analyze the performance of the vapor compression refrigeration cycle, this COP term is used to uh, which indicates the performance of the this VCR cycle, and this COP is denoted by your output upon input. So what is the output from this vapor compression refrigeration cycle is the desired output is your refrigerating effect. And what is input? So input is given in the form of electricity to the compressor, right? So this is the COP, and COP of here is given as a refrigerating effect upon work input to the compressor. Now come back to our main agenda for today's session, that is application of the refrigeration. So the mainly I have categorized the application of refrigeration in four categories. One is food processing and preservation and distribution, which includes meat, vegetable, milk, instant coffee, fruit. So for food processing, preservation, and distribution, there is a huge scope for refrigeration, and it is widely used there. Then in chemical and processing industry also, you can see for separation and liquefaction of the gases, which is used for the n number of application. So we'll see that liquefaction of gases means particularly for nitrogen production, liquid nitrogen production, this refrigeration is very much used. Then removal of heat of reaction in the chemical reactors, then recovery of solvent and storage of the liquids whose boiling point is low, is also for that you need refrigeration. Then there are some special applications that I'm going to discuss. That one of the application is manufacturing industry for cold treatment and for hardness of the cutting tool. This refrigeration is used, like one of the um, popular use is to keep your cutting tool at minus 100 degrees Celsius for 15 minutes in order to increase its life and hardness. Another application is in construction industry for setting up concrete, relieve thermal stresses in the wall, freezing of wet soil for excavation. In order to make excavation uh, quick and safely, you need to freeze the if soil is wet, you need to freeze it with the help of refrigeration. And in desalination also, you can see the application of refrigeration. And finally, the comfort air conditioning that we all feel in day-to-day life. If you go to malls, hospitals, or offices, you will see the air conditioning is used to maintain the comfort condition in that premises. So first, let us start with the application of refrigeration in food industry. So why food preservation? So any commodity or food product spoils in because of following three reasons. One is a microbial, because of the microbial activity. Second is oxidative activity, and third one is the autolytic spoilage, or which in short is called as the enzymatic reaction. So because of these three types of actions, the decay or the decay processes, these all three processes are related with the temperature abuse, and can be controlled. If you have to control this food spoilage because of the microbial activity, because of the enzymatic or the oxidative activity, which is already present in that food. So you have to control the temperature. If you are able to control the temperature, you can control the decay of the food, and you can increase the uh, storage life of the food in the control temperature environment, right? So what are the different factors affecting the storage life of the food is, of course, type of food stored, then temperature of the food, humidity, then air velocity inside the cold storage, and initial quality of the food, right? So let us see the temperature part. because in refrigeration we are interested more on the refrigeration side. So effect of storage life on various the useful storage life of food products is enlisted in the table. And as you can see that the first column shows the food products. So various food products are shown here. And these food products like meat, meat, poultry, dry meats, fruits, dry fruits, leafy vegetables, root crops, and dry seeds. If these products are not uh, stored under controlled temperature, means atmospheric temperature in our India, like hot tropical environment, this average temperature is above 35 degrees Celsius. So the life of meat and fish is less than 1 day. For dry meat and fish, it is more than up to 100 days. Fruits, it is only 1 to 7 days, or within a week, fruits may get spoil. And for leafy vegetable, it's hardly 1 to 3 days. So this, if temperature is not controlled, if it is controlled up to 22 degrees Celsius, or if it is in the region where average temperature is low, some northern part of India, then still you can find that the life is not significantly improved, and your products may get spoiled within a day or within a week or two, right? So but as you can see in the first column, if you store the food products at 0 degrees Celsius, you can see that its temperature, sorry, if its temperature is 0 degrees Celsius or below zero, you can increase the life from 1 day to 6 to 10 days for meat, and 2 to 7 days for fish, which is very very susceptible to this temperature, high temperature, and their spoilage, which is less than or only 1 days of useful life, is increased up to week, right? For poultry products, that goes up to 5 to 18 days. For fruits, it is 2 to 180 days, so nearly 6 months. You can improve the life from week to 6 months if you are able to, if you store at 0 or below 0 degrees Celsius. So such type of uh, as this table shows, you can increase the average useful storage life of these products, and with the help of that you can reduce the food spoilage. Then the recommended storage conditions are given here. For apples, you can store at a temperature 0 to 4, cabbage 0, cauliflower 0, then mushroom 0 to 4, potatoes 4 to 16 degrees, pumpkin 13 to 10 to 13, tomatoes 13 to 20. So the recommended temperatures with their relative friends, remember that apart from temperature, humidity is also important. So as you can see that the recommended humidity that you have to maintain is also mentioned here. Then maximum recommended storage life is also given, like particularly onion crisis is now we are facing. So as you can see that onion, if stored at 0 degrees Celsius and humidity is maintained between 65 to 70, then onion goes up to 6 to 8, can store up to 6 to 8 months. So such type of as per the different fruits and vegetables, if you maintain at this such a low temperature than the surrounding temperature, then you are able to increase their storage life. And in the country like India, where the food products are already um, at there is a shortage, and the seasonal variations are too high. So with the help of such storing the yield, when the fruits, vegetables, and grains are uh, produce in a larger quantity than demand, but you can use that excess production when there is a shortage by storing your fruits, vegetable, or food products in the cold chain. And that is very useful for food prices stability. Or second one is it also gives a good returns to the farmers. So there is a win-win situation if we are able to have able to store such a the agriculture output in the cold chains. Though India is lagging in this infrastructure, but there is a long way to go. There is lots of scope for you to in this particular industry. So again, next come to our domestic refrigerator, and this is one of the widely used, and we all using this domestic refrigerator in our day-to-day life. And as you can see, this is the front part of this refrigerator. Two-door refrigerator is shown here. At the top you can observe the freezer section, and at the bottom the normal refrigerator cabin. And at the top the temperature is maintained generally between -15 to -17 degrees Celsius, and at the bottom 4 to 5 degrees Celsius is sufficient. And as you can see that fan and motor at the top which circulate air in this refrigerator cabin, and evaporator coils which comes out through this the compressor, expansion wall, condenser is shown here. And at the back the four basic components of the VCR cycle like evaporator, condenser, compressor and expansion wall is shown here. The coil type of expansion wall is here. So a capillary, which is also called as a capillary tube type expansion wall. So these four components you can observe here, and this is the front and this is the back side of the refrigerator. And uh, at, at the end of this lecture, you just go to the refrigerator in your house and check out these and locate these four component at your home. The next application is in the domestic air conditioning. So in domestic air conditioning, again, the basic component or basic working principle is vapor compression refrigeration cycle. As you can observe here, the compressor is shown in blue, low temperature line is shown by blue, and high temperature by the red. So blue shows the low temperature line, and we know that low pressure and low temperature side is OP operator and compressor suction, then compressor exhaust to condenser and to the expansion wall. So this component, this basic VCR cycle is shown here. So this is a split type AC, you can say, where the evaporator and expansion wall is inside the room and compressor and condenser is outside the room as shown here. This first rectangular section is your evaporator, and compressor and condenser is here, which is at outside the room. And this domestic refrigerator, this cold air at 14 degrees Celsius is generally supplied, and coil temperature is generally 4 to 5 degrees Celsius, and room which is we maintain at 24 degrees Celsius. So this 40 degrees Celsius air goes to room, 14 degrees Celsius air goes to room, it takes the load from the or heat from the room, and its temperature increases to 24 26 degrees Celsius. That goes back to this evaporator, where cooling coil is used to cool it back to 14 degrees Celsius. So this is the domestic uh, air conditioner. Now next, for a large space air conditioning, like in case of uh, multiplex malls, where this domestic and as shown in this diagram, such type of small system will not help. For that you need a large system which will handle the thousands and lakhs of cubic of feet or lakhs of cfm of air. So for that you need such a unit known as the air handling unit, where you can see that a blower is shown, and this blower will blow out huge thousands and lakhs of uh, meter cube air per minute. And this air, as you can see that the outside air is sucked, and it is first filter out in this filter, then cooling coil, which is in this case in small IC it is like shown here, same coil, cooling coil, which comes from the VCR cycle is used here, which cools down the air, and this blower sucks that air and supply to the room, and that air is back, part of the air is supply back in order to improve the efficiency of this central AC. Part of the air is mixed and fresh air is also mixed. So there is a 50-50 or 75-25% of mixing of the fresh air. And this we call as the ventilation for huge malls, multiplex and everywhere. So this unit itself is called as the air handling unit. And at the back side you can see that the compressor and all that. So this is mini AHU. For very large system, the compressor needs are also in a kilowatt, hundreds of kilowatt, where You can see that a separate chiller room is there, and that output of that chiller room is nothing but the refrigerant at low temperature, which is used to cool here, right? So this is the AHU shown for central air conditioning. Again, the commercial air conditioning of multiplex is shown here. As we all go to movies, you can see that the chairs, and at the top or at the side, the various ducts are projected, and the ducts will supply the fresh air into the multiplex, so that will feel comfortable. So for the comfort air conditioning in the multiplex, for you can see that this central air conditioning, how it works. The AHU, the chiller room, as I discussed in the previous slide, is here, and that air which comes here as shown in the red arrow is comes out here, and it is distributed evenly in the room, so that the air temperature is maintained, and the part of the air is, I told you, is returned back to the AHU, and most of the air is exhausted because lots of uh, human being are present in the room. So the for in order to supply the fresh oxygen, the fresh air is mixed in this room, right? So one of the commercial application is shown. Then the same system, the layout of that multiplex refrigeration or air conditioning system is shown here. And first we'll locate the four components, that is your evaporator, then compressors, condensers, right, and expansion walls, right? So this compressor compresses the air that goes to the condenser rooftop, which is generally at the rooftop. As you can see in this diagram, these are the condensers. So these condensers cool down the refrigerant, then that goes to the expansion wall, and expansion wall to evaporator. So this is a multiplex direct refrigeration system. In second is the commercial, again commercial air conditioning, but with secondary loop refrigeration, where refrigerant is directly is not supplied to the evaporator. Instead of that, brine is used. So in between you can see the additional heat exchanger is placed, and where the refrigerant from this VCR cycle is used to cool the brine, and then this brine is then used to cool the room, or it's supplied to the cooling coil of the air handling unit. So such type of commercial air conditioning is shown here. Then next application is in automotive air conditioning. In automotive air conditioning, as we know that when we seated in the car with the other passengers, there is a metabolic load, our respiration, and the sweating adds the uh, heat in the room, plus engine load, as well as the heat from the sun direct radiation and diffuse radiation in the room. This leads to heating of the air, plus because of metabolic activity, oxygen level is also reduced, the respiration oxygen level is reduced. So for that, the ventilation is needed, and that ventilation is nothing but refrigeration and air conditioning system. So this refrigeration and air conditioning, that we all aware of, with the help of this controller we can control the temperature. And for fan, this is a left hand side, this is a temperature controller, blue and red. And on the right hand side, the various the ducts through which the air is distributed in the car is also varied, right? And this the at the center you can see that the controller temperature setting, in some cars it is 0 1 2 3, but for nowadays we are having a precise temperature control with which shows the actual temperature inside the cabin and the temperature that you have to maintain. So this VCR, again you can observe the vapor compression refrigeration cycle, like compressor, condenser, evaporator, and expansion wall nearer to evaporator. And this air after evaporator is circulated in the room in order to take this load from the various sources discussed earlier. So this is the application of refrigeration and air conditioning in the automotive cars. The next is the cold storage. As we discussed, the foods, fruits, and other vegetables, etc., needs to be stored at a particular recommended temperatures in order to increase their shelf life. Such type of cold storages are built with the shelf and and you can see at the center such type of evaporator. One of the evaporator, which is the forced drop evaporator, is shown here. This evaporator is nothing but having the cooling coils, and fan blows the air, which actually recirculate the air in the room. So such type of cold storages are, you can see in the, the for storing and increasing the shelf life of the food or fruits, vegetables. Again, if you go to supermarket or the store, you can see such a type of uh, storage casing having the refrigeration system attached to them in order to increase the shelf life of these products, right? One of ice cream display is shown here. Then frozen meats and various other products are also shown at the left hand side of this slide. Clear? But the working principle of it's again same at the bottom of this casing, at the bottom of this uh, display cupboards, you can see that the compressor, evaporator, compressor, condenser, and expansion wall is shown here. And with again with the help of vapor compression cycle, this at the evaporator, as you can see that blue indicates that the chilled air, the fan or the blower blows the cold air or blows the air over evaporator, where that air gets cooled down, and that air is then circulated inside this casing as shown here, where the food products are stored. And continuously this cycle works, and this warm air after it is sucked back by the blower is then uh, exhausted out, right? So such type of food storage casings are widely used in order to increase the shelf life of the products, dairy products, or the meat, ice creams, etc. Clear? So this is again for in order to keep the vegetables at the fresh at the store, such type of casing. But this casing is having one additional thing apart from the temperature. They also maintain the humidity, so they moisturize the vegetables by either manually spraying the water or with the automatic sprinklers. So vegetable storage and it increase the vegetables life from 1 or 2 days to up to 1 week at max. Clear? Then storage of dairy products, again as you can see that the evaporator coils are shown at the bottom, and dairy products are stored like this up on this. Clear? And evaporator continuously circulate the cold air inside this casing, which will helps to increase the shelf life of these dairy products. Then next application is ice maker and ice bank evaporator. And this ice bank evaporator commercial product is shown on the left corner. And on the right hand side, you can see the layout of this ice maker machine. And this ice maker machine, you can see that it is again comprises of compressor, condenser, expansion wall, and the evaporator, where in the evaporator the water is supply whose with the help of which you are going to produce the ice. And this ice maker is then this temperature is maintained below 0 degree celsius. So when the water is circulated in the ice maker section, and it will readily convert that water into ice, and these ice are taken out from this at the dispenser side, right? So such type of ice making machines are widely used. Then second application for ice for large scale, when you require ice for hundreds and in thousands of tons ice you have to produce, then such small system will not help. You require a huge ice plant. So as shown here, such a brine tanks, insulated brine tanks are prepared for that, which will handle the tons of ice, tons of water is converted to ice in these cans. And this brine in this diagram is nothing but water plus glycol mixture. And this in order to keep the brine temperature at, generally it is kept at -8 to 10 degrees Celsius. And this is maintained because of the vapor compression refrigeration cycle. Again, your compressor, condenser, expansion wall, and evaporator. So this VCR cycle plays its role, and this water in the can, which of which the ice you have to prepare the ice is readily cool when this brine these cans are immersed in the brine tank, which is maintained at -10 degrees Celsius. It will produce the ice, and this ice is then taken out by lifting with the help of crane, because it's 200 kg, 500 kg ice cubes will be prepared, and this ice cube will be then taken out from the cans like this, as shown in the bottom of the slide. Okay, so such type of ice plants are there for commercial production of ice. Then next application is in water coolers. So water coolers are used in public buildings to provide the cool drinking water. Uh, so it is similar to ice water, and there are typically two types of water coolers are available. One that has a large bottle, inverted bottle, as shown in the first diagram, figure A, and one that is under regular main water line. Okay, the city water line is shown, and it will readily convert it into uh, the uh, the cold water that you can drink. Clear? So there are two type of water coolers. I think one of the water cooler bottle type water cooler, we all aware of. Okay, everywhere you go, such small system of inverted bottle, this filter water bottle is inverted like this, and at the bottom it is nothing but again vapor compression cycle is a compressor, condenser, expansion wall is shown. And after the expansion wall, that refrigerant goes to this evaporator, where the heat exchange between this cold the water that you have to uh, cool, uh, and the refrigerant, the heat exchange between these two takes place, and this cold water is then taken out from this water dispenser section. You can keep your glass here, and this cold you will readily serve with the cold water. Okay, so this is a water cooler and its working principle. Next application of this uh, refrigeration is in for dehumidifying the compressed air. Right, the compressed air, we all know that compressed air is used for various application in the industry, for CNC or for pneumatic tools. The refrigerating sorry, the compressed air is required. But we all know that in the atmosphere, the air is air is having the moisture contained in it, right? So while compressing that air, compressor also compresses that moisture, and if that carries over to the various pneumatic tools and other applications, that may uh, leads to corrosion and other problems in that particular pneumatic machinery. So you need to remove moisture from the compressed air. So as you can see that in order to remove the moisture from compressed air, first this compressor is shown here, air compressor with its controller. But after that, one refrigerated air dryer is fitted to this compressor. So when the compressor compresses air, it is stored in the receiver tank, and this high pressure air from the receiver is taken to refrigerated air dryer, where moisture from that high pressure is removed, and which is drained to the drainage. Clear? So again, the same layout of a refrigerator air dryer is shown here. So high pressure air storage tank, to it goes to refrigerator air dryer, and then this moisture is removed from here. Again, the same refrigerator air dryer is shown, refrigerated system at the bottom, and at the top you can see that hot compressed air from the receiver tank is taken to first stage heat exchanger, then second stage heat exchanger, and this humidifier is taken dehumidified fied air is taken out from this air dryer. So this is refrigerated air dryer is widely used in the industry to dehumidify the air. So next application is in truck refrigeration system. We know that one of the important part of the cold chain is the logistic. okay, to take the food products or the fruits vegetables from farmers or from cold storage to the customer. For that you need logistic transport of these products. So while transporting, there are a number of hours and days required to transport from one place to another. So in between, if you are not keep the temperature of that vegetable or food products within the recommended temperature, then it may leads to spoiling of the food products while transporting. For that you need to have a refrigerated trucks as shown here, and these refrigerated trucks will help to maintain the temperature of the food products as recommended, and increases, and they keep its shelf life intact. So for that, first you can see that some of the trucks are having liquid nitrogen, and this liquid nitrogen is used to keep the temperature of inside the cabin of that truck, or the storage the container inside the container temperature within the recommended, right. The second part shows the VCR cycle is attached to this container, and this VCR cycle supplies the cold air or the chilled air to the container, and this will keep the temperature or maintain the temperature of food products. So you may use liquid nitrogen or VCR cycle as shown here. So of course this VCR cycle, to run the VCR cycle you need the power. So for this, power is taken from the engine in most of the cases, right. So next application of refrigeration is in food processing industry, and out of which I will explain the quick freezing method, which is quite popular nowadays as packaged food we are talking about. So this packaged food, for packaged fooding or packaging, you need these quick freezing methods. So when food is frozen, the one important thumb rule or the principle you need to remember is that the faster the temperature is lower, the better the quality of food, right. Those, this is you can say the very very important thing while you are going to frozen the food. Try to um, freeze it as fast as possible, okay. If it will take more time to freeze, then it may spoil the product, or it will not yield the desired result, okay. So uh, individual quick freezing method or quick freezing methods are quite popular, and as shown in the first blast freezing tunnel, that the output from the VCR cycle, that is the liquid refrigerant, is comes here, and this liquid refrigerant is then uh, supplied or with, or that is used to cool the air which is circulating inside this tunnel. And this tunnel is temperature is maintained as suppose minus 40 degrees Celsius, right. Minus 50 Fahrenheit is approximately minus 45 degrees Celsius. So temperature of this tunnel is maintained at minus 45 degrees Celsius, and the products, food products that you have to quick freeze are keep like this in the container. And when these products moves in this section or in this tunnel, this air is blasted with the help of blower. This low temperature or chilled air is blast over these products, and they will be um, cool quickly, okay. Instead of our domestic refrigerator where temperature is minus 10, minus 5, or 5 degrees Celsius, it will take lots of time to frozen these products. But as the temperature in the tunnel is minus 45 degrees Celsius, these products are quickly frozen, and that is good for the uh, as far as the quality of this frozen food is concerned. Then second is conveyor type of blast coolers are also shown. Instead of the tunnel, the conveyor at the bottom of the conveyor, as well as on the top of the conveyor, such a air low temperature air is blown over these products, so known as a conveyor blast coolers. At the bottom, spacing of food products, like for this tunnel is shown here. So spacing of the products is very important, which will quickly or individually freeze the products and increase improve its quality while maintaining. So next application is in dairy industry. So in dairy industry, as shown here, the milk, raw milk is taken out, and it will be used for the cheese making. Parties goes to butter making and other processes, like particularly we are interested in skim milk. So this skim milk is goes here, and after that this milk is goes for pasteurization process. So in dairy industry, pasteurization, we all know that is the process where you are initially heating that milk up to 75 degrees celsius, and after heating it is suddenly cooled to 5 degrees celsius, right? So this cooling from 75 to 5 degrees celsius in a very short period of or few seconds is known as a pasteurization process, where lots of bacteria are going to kill or their activity is now uh, uh, is now reduce, right? And this pasteurized milk is then goes to homogenization, and this milk is then stored into the bottle or pouches, clear? So milk is stored generally at 3 to 4 degrees celsius, and the other product of this dairy industry is ice cream, which is stored as minus 30 degrees celsius, which we'll see in a while. But this milk, the temperatures that you have to maintain at various stages of the milk processing, it's shown on this flow diagram. As you can see that milk, initially the milk, raw milk is stored at 5 degrees celsius, then it is pasteurized from 75 to 4 degree, then standard the milk at 5, then pre-pack liquid milk, and milk storage as up to 2 degrees celsius. So these are the various temperatures for the normal skim milk processing. And for other other processes for cream, butter, etc., the different temperatures are given. So in dairy industry, the application of refrigeration is also huge. Again, in the same dairy industry, ice cream processing is shown in this slide. The raw milk is taken and then supplied to mixed tank, homogenizer, heat exchanger, where you are actually dealing with the refrigeration and air conditioning, refrigeration particularly. Then it goes to cooler, aging and salting vat, then continuous freezing or batch freezing of that ice cream is done, and then packaging, hardening of the ice cream, and then storage and distribution through the trucks or the refrigerated vans. So this is the ice cream processing, where refrigeration plays a very important role. Next, the special application of refrigeration is given in this slide, which is a freeze drying. So why freeze drying? So in order to keep the maximum nutrients and bio active compound retention in few products, you need, you will not going to cool or slowly cool down or the freeze the products in the conventional way. For that you need some out of the way cooling known as a freeze drying. And this freeze drying is very very important and widely used for some special materials like meats, coffee, juice, dairy products, cells, and some bacteria, as well as for penicillin, hormones, blood plasma storage, clear? But the disadvantage of this method is that it requires 4 to 10 times more energy than a regular drying, clear? Because as it is a drying process, but drying is not done in the conventional way. For that quick and freeze drying is done, so moisture is removed by drying with the help of the very cool medium like a liquid nitrogen in this case, as shown here. So for that, let me refer the first diagram as shown here. The liquid uh, is or the substance whose you have to dry freeze your the substance that you are going to dry freeze is supplied here, and gaseous nitrogen is again supplied to this container. Then liquid nitrogen is already there, and this liquid nitrogen will uh, cool down quickly, cools down that the coffee, for example coffee in our case is to minus 100 and less than that temperature. And because of that quick freezing of the that coffee is done, and this freeze frozen granules of the coffee then supplied to next section, and where it is attached to the other section which is having condenser and vacuum pump. So this vacuum pump is used to keep the vacuum to keep the pressure of this section below the vacuum or below the 0.612, that is a triple point of water, and which will readily removes the water, because at suppose for example here temperature is minus 100 degrees Celsius, so water is in solid form, right? It is an ice crystals. But when it is exposed to this vacuum container, when the granules of coffee with the moisture in that, or the crystals in that, so it will readily, because of the vacuum, it is sublimates, clear, and the sublimation of that solid, so solid moisture, or in the ice form, it sublimates to vapor, and which is taken out from this section, clear. So such type of freeze drying is used in order to keep, as I told you, to keep the maximum nutrients and the flavor of the coffee as it is. So freeze drying is the only option. If you are doing the drying the coffee with the hot air, then it may leads to the flavor will go, some nutrients will go. So this freeze drying is very important. Spices, for example, for the spices grinding is done in with the help of this freeze drying, right? As shown here, the triple of point of water is shown here. So you can start from this atmospheric pressure. Initially this your coffee is at A, then if you slowly reduce its temperature up to this, and after reducing temperature as shown here, it is at this point, and suddenly you can reduce the pressure in the second section from 101 kilopascal, means 1 bar, to point 6 kilopascal, means vacuum. And because of that sublimation, as you can see that below the this triple point of water at point B, final final point is your desired final condition for sublimation, where readily the moisture or the liquid crystals of the water are sublimates to vapor, and which is taken out. So such type of freeze drying is explained here. The next interesting application is in construction industry, where the ground freezing with the help of liquid nitrogen is done. And why to do ground freezing? So ground freezing is done in order to uh, handle this unstable soil and loose sediment portion of the soil, and for the excavation purpose, particularly for tunneling. This is very challenging when the soil is unstable and very loose sediments over the tunnel. So in that case, the liquid nitrogen as shown here, this wire, the pipe of liquid nitrogen, and this liquid nitrogen is first supply, or then uh, it is passed to the soil where you are going to bore the tunnel. And because of this liquid nitrogen, the soil gets hardened, and you can easily bore the tunnel in that ground. So it is for safety purpose, it is very good, and it will avoid the collapsing of this section, or the collapsing of the ground above the tunnel, and which makes the construction easy, as shown here in the first diagram. In the second diagram, concrete cooling is also very important, where the liquid nitrogen, where you can see that liquid nitrogen is mixed with the concrete, and which will freeze the crystals of the moisture in that concrete, and that may relieve the stresses, okay. And cracking, which avoid the cracking after when the concrete is settled, the thermal stresses will be relieved because of this freezing, and then cracking of the dams and all that you can avoid. So there are lots of application in construction or in civil industry also. So with this I conclude today's session. I hope I made the application of the refrigeration and air conditioning clear to you, and we'll see in the next lecture with the basics of vapor compression cycle. Till then, keep tuned. Thank you.